Hello everyone, my name is Jason Fitzgerald, and for my project I want to learn about data support systems or data decision modeling in R, and I wanted to learn how to do things like decision trees and random forests in R and see how data is able to help you find ways like maybe what's the best way to sell a product or how to minimize risk with data. And so I'm going to try to just focus on the decision tree models and random forests, and I'm not going to explain a whole lot about what R is or what it does. R is a statistical programming language that's really helpful with visualizations and doing statistics and doing things like this with trying to do these data support models. So there's going to be a few tutorials that I'm going to try to explain as I've been doing my research that I found online. And to start off, these are the packages that I'm going to be using. And to start off, we're going to be looking at how to make a simple decision tree with some Titanic data. And this was the tutorial that I was following to do that. These first few functions, it's setting a seed, which will just make sure that if anyone else is trying to reproduce this, that you're going to be getting the same results. And this theme set, it's for plotting, and they wanted it to have some minimal styling. And so we're going to pull in the data, and to kind of give you a sense of what this data is, it has the passenger ID, if they survived or not, their class, name, sex, age, and some other different variables. And to first make this a simple decision tree, what we're doing here is we're changing this survived column to whether if they survived or they died, just so that it's a lot more simple to see in the decision tree. And also with the functions that they're using, they're changing a couple of the columns to factor, because with the functions it's a lot easier for the tree function to read if the columns are factors. And so this is what it looks like now. It changed the survived column and it changed them into factors, the sex and survived into factor columns. And now we're going to make a tree, and we're going to see if someone survived based on their age or sex. And so this is going to be a simple little decision tree. And this summary kind of tells you what the specs of the decision tree and how well it is. And an important thing to note is this misclassification error rate at the bottom. And right now it looks like 21% of the data that it has using this decision tree, it will be 21% of what it would classify is wrong. And so we want to take a look at this decision tree, and we're going to plot it out. And so pretty much if you're a female, you're going to survive. And if you're a male, if you're under the age of 13, you have a better chance at surviving than if you're over 13. And so that's just a simple decision model of a simple decision tree. And so now we are going to be looking at a lot more than just their age and sex. We're going to be looking at all the other variables to see the likelihood of if someone survived or not. And with using all the variables, it didn't change the error rate a whole lot. It only dropped it by about 4%. And so even with adding these other variables, it only drops down the error rate by 4%, which isn't a ton. And one of the things with decision trees is you want to try to make the best decisions with the fewest decisions possible. And this isn't too complex, so maybe it is better to add in these extra variables. But if we can see that if they are a female, then and if their class was less than 2.5, then they survived, and if their fare was lower, then they survived. And then, yeah, for males, they just had it more rough than the females. But yeah, they died if they were less than 9, and they didn't have a lot of. I can't remember what this siblings SP means, but yeah, if you were a female, you have a better chance at surviving the Titanic. And so this was just a great tutorial for me on learning the basics of decision trees. And then this next one kind of goes in a little bit deeper. They're using these car seats sales data, and this is just kind of showing a histogram, and what they're planning to do is to split the sales into whether it's high or low. And so they're looking at this histogram to see where they should split the data, and they decide to go with 8 to try to split up those cells between a high cell or a low cell. And so they're just adding it into their data, and then now they're going to be making a tree based on all the columns, and they want to try to predict the cell. And we're also going to take out this cells column because we made this high column right here, which is essentially the same thing, and it will pretty much, of course, cells would have the highest correlation because it's pretty much the same thing. So we're going to take out the cells data there. And so this is the summary that it gets. It looks like 9% it misclassifies. And if we plot it out, it looks like this. And now this, it's kind of a little bit harder to interpret. You have a lot of these different decisions which you may or may not want, but you're looking at, okay, does it have a bad or medium location? If it has a bad or medium location, is it greater than this price? How was the advertising? What was the comparable price? And then it goes into all these different decisions, and sometimes the margins aren't super great, and for a business it would be hard to try to look at all these individual decisions, and sometimes it can be harder to interpret. And the reason why I liked this tutorial is that it will go through in how to prune these trees to kind of focus on the best decisions possible. And so, and if you can actually print the tree and look at the probabilities that it has as it goes down the different branches of the tree. And so, yeah, you can see the probabilities on the end and whether it was no or yes, true or false, and things like that, and what was the most likely path to go. And so now we're going to make a training set for the model to train a model to try to predict the cells, whether it's going to be a high or a low cell using this data. And we're just we're pretty much going through the same thing again. And now it's going to try to make a prediction based on this training data. And this is also another way to look at the error rate of how good your decision tree model is doing. So right here you have your predictions and whether it was high or no, and your correct ones are on this diagonal left to right. So your high was a no, your prediction was a no, you got 72, but with your prediction you got a no, but it was actually a yes for the high. And so this and this right here are the correct ones that you predicted, and these two are what you missed with the predictions. And so now this is kind of a cool function because it will prune. Actually, this just kind of makes different things to kind of visualize the best way to prune a tree. And this plot's kind of hard to understand for me, but it kind of shows the size of how many nodes you should have and kind of how dense they are. But this is kind of funky with the lines going up and down. So another way to do it is to actually put in size and the dev right here, and it kind of makes a dot plot of, or kind of a scatter plot, a point plot of where they all are. And so it looks like one of the best ones in the tutorial, they had 12, and it's kind of interesting trying to look at these plots because in a lot of tutorials they say to try to get one of the best elbows but at one of the lowest points, and so sometimes it's hard to figure out which is the best, and it's kind of up to you to decide which is the best, how many nodes to pick. But they chose 12, and 12 looks like to be a good number because it's still going down. And yeah, so we're going to prune our trees to kind of the best 12 nodes, and we're going to plot that, and that's what it looks like. And so yeah, this narrows it down to a lot fewer of decisions, which will make it easier to decide what's the best way to sell these car seats. So if the shelf location is a good location, and if the price is lower than $135, then they have a better chance at buying the car seat. If it's in a bad location or a medium location, there's a few more variables to consider on whether or not someone's going to buy their car seat. But I thought that was very useful to learn with how to prune these trees to make them better and to make them with fewer decisions, because that's the point of these decision trees, is to make the least amount of decisions but getting the best results possible. And then this kind of shows the diagonal with just these 12 nodes, which we can see is we got 74, 39 correct, and I can't remember. And so they're pretty much about the same with the pruning. And so you might want to go with this decision tree just because of it has fewer decisions, and it'd be easier to make your business model off of these decisions than that other plot that we had with all those decisions going everywhere. And so now we're going to move on to random forests. And what a random forest is it makes a bunch of these decision trees. And what you'll do is you'll decide how many variables you want to look at for each different decision point. And what a random forest will do is it will choose the best variable out of the three variables that you choose, and then it will go down to the next decision in that branch, and then pick the best decision that correlates with the last one, and it will go down and make those decisions, but then it will make a bunch of these different decision trees, and it will kind of average out all these decision trees and to give you the best predictability of what variables are the best with predicting whatever you are trying to predict with. And so with this one, they're using birth weights of children being born, and some of the data we'll be looking at is if the mother has a low weight, what race they are, if they're smoking or not, and yeah, some other variables. And so yeah, we're just getting in the data. I thought this was kind of a cool function, the sample split. It will take your data and it will split it up into a training and a test data set with however much you want to have using to train your model and how much you want to be testing with it. And so this is the random forest function. And so this mtry, these are the number of columns that you want to try out with your decision with your random forest. So it will choose 3 different columns to try to make the best, to see which has the best correlation with what you're trying to find. And we're going to try to find what's the best predictors for a low weight baby. And this n tree is the number of trees you want to create. And so with this model random, we'll take what the results from this random forest function. And so this mean increase Gini is also important. So this importance shows the kind of the importance of the columns. And the higher the mean Gini, the more the more likely it is to predict the variable that you're trying to predict. So the birth weight is the best way to predict whether or not wait, that's not right. Another thing that you can do to look at the different columns that you're using, I'm going to hurry and look and see what these different columns mean. Okay, so low means the indicator of birth weight less than 2.5, which is what we're trying to predict. And okay, yes, the birth weight is the birth weight in grams, so that would make sense that the birth weight is the best indicator of whether or not it was a low birth weight. And so you can also plot them out, and yeah, the higher it is on the plot, it is better. And also, another thing to realize is that the more variable a column is, the more likely it is that it can predict whatever variable you're trying to predict. So if we actually look at what's in the data, we can see that birth weight, there's a lot of variability with this birth weight, 709 to 4,990, and this low weight also goes from 80 to 250, and as we can see, the variables with the most variability has a better chance at predicting these variables. So yeah, birth weight is a good way to tell whether or not they're going to have if they have a low birth weight, their LWT, mother's weight in pounds at last menstrual period. It's another good way, age, and so on and so forth. And so then we have these predictions with class. And oh wow. So this will predict your model, and it will make this prediction, and then it will test it on your actual data according with your test data, and it will make this table. But with this one, it has 100% accuracy with with the random forest that we have right now. So it's a pretty great random forest that we have. But this will give you a percentage to show how good your random tree is. Then I'm actually not too sure what this type class and the type probability is doing. So if you know exactly what those things are doing, you can kind of help me out with understanding more about those functions. But this tune RF, this is also a great function because this will help you tune what your random tree, and it's kind of a simple plot, but this will tell you how many different variables you should try at each decision point. So this mtry3 right here, this function will help you predict what's the best to put right there with for your number of variables that you should try. And then you can also show that if you try 3 variables, this OOB error, it stands for out of the box error, and so the lower that is, the better it is, because that's the less error that you're going to have with your model. And so putting all the different things that I learned with random forest and decision trees, I went on the internet to look for some data, and I found some data to use to try to predict students' grades, a different number of factors, and I just wanted to put to the test with what I learned and see if I could understand it myself. And so I found this data to predict students' grades, and I pretty much wanted to tell if they were going to pass or fail a test, or not a test, but fail or pass a class. And the grade variable goes from 0 to 20, and so I just decided to split on 10, and if they got less than 10, they were going to fail. If they got more than 10, they were going to pass. And so now I'm going to try to find the best predictors with trying to predict whether or not they passed a class. And right now it's doing pretty good. We have this about 4% misclassification error, and we're going to plot out our decision tree, and it looks like it is heavily based on how you're doing in your class too. So there's 3 classes that it's using for the data. It has period 1, which is G1, period 2, which is G2, and period 3, which is G3. And then it has these are all the different columns that it has, and this is kind of a data dictionary explaining what's in the data. And so you have their study time, travel time, sex, age, family size, and these other different variables. And so we can see grade 2, if they got less than 10.5, because we want to know if it's greater than 10. If they have greater than 10, if you have greater than 10.5, you're most likely to be passing the class, unless if your addresses are. What does that mean? Okay, unless if you're kind of in a rural spot, then maybe you have a less chance of passing. But yeah, so this is kind of a simple decision tree based on some grades, and we can also look at the decision tree that way to look at the different decisions, and then I'm going to train some data on it and then plot some more stuff out, and then try to predict with the different training, with the training data set that I had. And with my predictions, it looks pretty good, 56 and 78. And so now we're going to try to prune down this tree to come up with the best decisions. And with this, it looks like we are doing pretty good with just having 2 nodes, which if we try to do that, it pretty much is your period 2 class is the best indicator with whether or not you're going to pass or fail your period 3 class, which kind of makes sense. If you're getting good grades in other classes, most likely you're going to be getting good grades in your other classes. And so yeah, even with pruning it, it still looks like the same for the most part with the predictions. It did the same. So you can predict just as well with using one variable as you can with using a couple of other variables. And so now I'm going to be doing this with random forest, and I'm going to make some training and test data for random forest to try out. And so yeah, this shows that your period 2 and your period 1 are the best indicators, and also the amount of absences, or at least the absences you have, also goes into whether or not you're passing or failing your class. And most interestingly, your mother's job, and these other ones look to be pretty close with predicting your grade for period 3. And so yeah, now we want to actually, I kind of skipped this part because this doesn't do super well with what I'm trying to do with this data set. But then with the tuning, you can try to see the best number of tries, and for how many I should be putting up in the sum try. And you can run it a couple of times, and sometimes the number will change. Maybe it's 30, maybe it's 25, and yeah, it's hitting 30 a lot, 21, and so we could come up here and maybe do 20, well, not 121, 21 different columns to try out as it's trying to make this decision tree. And yeah, it's going to say, yeah, your grade 2 is the best with predicting this. And so that's great, but what if we just want to figure out the likelihood that they're going to get a good grade in period 3 without using their period 1 or 2 scores? And so I thought that would be kind of interesting to look at. So I'm going to take out their grades for periods 1 and 2 and go through that data. And I'm just going to go through it super quick just so you can kind of see that. So we have a lot more different decisions to choose from when we take out the other 2 periods, because it needs to try to figure out the best way for these students to pass their period 3 with kind of using these outside factors besides their other grade scores. There are some of the probabilities, and trying to predict with the training model. And as you can see, without the other periods, it's a lot harder to predict, and we don't get too good of predictions with trying to do it this way. But we're going to plot, and it looks like around 6, you can do it around with 6, but maybe if we run it a couple of times it will change, so maybe 12. We'll go with 12 decisions, so the best out of the 12 different nodes, or maybe we can go with 6. So failures, it looks like if you're failing a lot, then you are not going to be getting a good grade, it looks like. But yeah, it's still not giving us super good results, but I thought it would be kind of interesting. And now we're going to do some, whoops, forgot to pipe that in. Object G, okay, so now we're going to use random forest and look at, and it looks like that failures has a little bit more of a better predictor than absences when we take out the different grades that they have for their other 2 classes, and Mother's Job is still pretty high, and so yeah, and so this, it shows pretty strong correlation with just trying out 12, but then it goes down to maybe 19. We're trying to figure out with this elbow plot, and again, it's kind of up to you to decide what's kind of the best. So let's try 19. We'll try 19 variables and see if that will change our results any. Okay, with this it puts absences at the start, but it looks like absences and failures, when we don't have the grades, does the best with predicting whether or not someone's going to fail or pass. So there is what I learned with the different things as I've been trying to study data support systems, and the best ways with trying to figure out how the best way to make decisions with data and only using data. But again, you need to kind of plot these out, look at the different probabilities, and find the things that make the most sense, and then base your decisions off of that. But with trying to predict these grades, something that I learned is if you have grades for other periods that a student is taking, it's going to be a good indication with how they're doing in other classes. And as long as they're going to school and don't have a lot of absences, that's probably a good predictor with how well you are going to be doing in a class. And so yeah, I hope that you guys were able to learn a lot of stuff. I had a lot of fun learning this, and I wish that I would have spent more time. I didn't with learning the R part and R plot things that Brother Carver has been using. I didn't find a whole lot of tutorials on that as I've been learning this, and so yeah, I'm wanting to learn more, and yeah, I hope that you guys were able to learn some things as well.